Hello everyone, welcome you all for this video lecture. Let me introduce myself. I am C. Usharani, Assistant Professor in the Department of Artificial Intelligence and Data Science from Ramco Institute of Technology. Now I am going to discuss about selection chart in data structure. This is the overview of my video lecture and these are all the topic I am going to discuss for this selection chart. First one is definition and the next algorithm for selection chart, one example program and working process of selection chart and selection chart algorithm analysis, that is time and space complexity. Last one is merits and demerits. Before getting into this topic, we want to know the difference between charting and searching. Searching is nothing but we will search the element in a given array. But charting is a technique can be used for rearranging the data elements present in an array in any specified order, whether our order is descending or ascending, whatever we want. There is a lot of charting algorithms are there, such as insertion chart, merge chart, bubble chart, quick chart, heap chart, etc. Here we will going to discuss about selection chart. In this chart, we have to select the minimum element from the uncharted array in the each iteration and swap with beginning of the list. In the charting, the given list can be divided into two sections. One is charted list and second one is uncharted list. From this, we have to pick the minimum value from the uncharted section and place it into the charted section. This process will continue until all the elements are placed in the right place. So this algorithm is simply called it as simple comparison charting algorithm. This is the algorithm for selection chart. First we will specify the length of the array. Suppose the given array contains the 6 element means our length of the array is 6. Next, we set the first element as a minimum element. For each uncharted element, compare with minimum element with the second element. If the second element is smaller than the first element means we assign the second element as a new minimal. After each iteration, the minimum element is swapped in front of the uncharted array. This process goes until we find the last element. This is the Python program for selection chart. In this program, first we will define the function named as selection chart. Next, we have to get the elements in the list. We need to determine the number of passes to be made when comparing the values. It can be used the two loops. One is outer loop and inner loop. In outer loop, it uses the n minus 1 iteration. That is, our value is 5 means it to produce 5 minus 1. That is the 4 number of iterations are doing. In each iteration, the value of the variable I is assigned to the variable minimum value index. It is indicates as min index. In inner loop, it uses the I plus 1. It does not start with 0. And it uses the loop to compare the leftmost value to the right hand side value. At last, it finds the minimum value in the uncharted list and places in the proper position. And it updates the value of the minimum value index when swapping condition is true. Next, we are going to see one example of how this uncharted array is implemented by using the selection chart. Here, our uncharted list contains the 5 elements such as 21, 6, 9, 33 and 3. In step 1, the first element 21 is compared with the remaining element. So, it found that 3 is a minimum value. So, the position of 21 and 3 are swapped. So the value with the green color represents the charted list. In step 2, the value of 6, which is the first element in the uncharted list, is compared with the remaining elements such as 9, 33 and 21. So it found that 6 is the minimum element compared to remaining. So 6 is maintained the same position as such. In step 3, 9 is compared with the rest of the elements such as 33 and 21 to check the minimum value. Here the value 9 is the minimum, so it maintain the position same in the shattered list. In the fourth step, the value of 33 is compared with remaining only one element, that is 21. Here it found that the value 21 is lower than 33. So this position of 21 and 33 are swapped to produce the new list. In step 5, we only have the one value left in the unpartitioning list. So therefore it is already in the shattered list. So this is the selection chart algorithm analysis, that is the time complexity and space complexity. So what is meant by complexity? The complexity is used to express the number of execution time it takes to chart the list. Here the charting implemented by using two loops. One is inner loop and second one is outer loop. So it can use the order of n square time complexity for best case, average case and worst case. So n is nothing but the number of elements in the given array. And this selection chart algorithm can use the space complexity of order of 1. Next, we will discuss about the merits and demerits of selection chart algorithm. So, compared to the other algorithm, the selection chart algorithm produces the advantage searches. It perform well on a small list. Next one is the space efficiency. That is, the selection chart requires the minimal additional space beyond the input array. So, it requires only the additional space for storing the temporary variable. Next one is simplicity. The selection chart is easy to understand and implement. So it is making a good choice for beginners. Okay. So next one is disadvantage. This selection chart algorithm produce the pure efficiency when dealing with the huge list of items, and it requires the n number of steps for charting the n elements, and it is not the optimal. That is, the selection chart algorithm can chart any input array in the minimum possible number of comparisons and swaps. Thank you. Thanks for watching.